Hello and welcome to the Deep Sea Podcast, Pressurised, a short, punchy version of our main feed that gets right to the scientific point. If you like what you hear and you'd like to hear the full episode, you can find it in the same feed. And now, to get right to the point. We like to bend the rules a little bit of the Deep Sea Podcast because sometimes real weird outliers actually inform our understanding of the deep sea. And one of those really interesting places that's lodged in my brain ever since I heard about it actually is Lake Baikal in Siberia. So we dug around for who would be the best to speak to about this area and came across Professor Marianne Moore. She dropped in for a chat about this incredible place. I'm joined by Professor Marianne Moore, a Professor Emeritus of Biological Sciences at Wesley College in Massachusetts, USA, and her research focuses on the biodiversity and environmental changes in Lake Baikal in Russia, where she has worked for more than 15 years. Specifically, Marianne is an expert on the ecology of the freshwater zooplankton and of human impacts on the lake. Thanks so much for coming to have a chat with us. I'm super excited about this one.
Oh, I am too. Lake Baikal is my favorite lake, and it's a treat to be able to talk about it and share my excitement with others.
I'll let you sort of start off with putting the lake into context.
Let me begin by talking about where it's located. It's located in southeastern Siberia, so it's 200 miles north of Mongolia. Now, before I explain some of its unique features, for example, its depth, its volume, I'd like your listeners to imagine a lake shaped like a gigantic crescent moon. It's very long, narrow, towered by mountains, and it fills a gargantuan crack in the Earth's crust. And the deepest point in that crack is over 1,600 meters deep. So the lake is more than a mile deep, and it's getting deeper and wider each year by about 6 millimeters per year in depth and wider by about 2 centimeters because the lake is located where two tectonic plates are pulling apart. And because of its great depth, this is the largest lake by volume. To fill it requires emptying all of the North American Great Lakes combined, which adds up to 20% of the Earth's liquid fresh water. Now, this is, by some estimates, the most biotically rich lake in the world. Tremendous speciation has occurred here, and it is sometimes referred to as the cold Galapagos. So those are some of the features that make this lake very attractive to aquatic scientists.
The more I learn about it, the more it just grabs me. It's just as soon as I think that oh, well, that's incredible, then I'll read another bit and it's got a whole extra layer to it. Before we get onto the specifics, how did you sort of discover it? How did it grab you?
Well, all freshwater scientists know about this lake because it's so unusual. Being the deepest, the largest by volume, the most biotically rich by some estimates, and it's a very ancient lake, one of the two oldest lakes in the world. So again, it's like the holy grail or El Dorado for freshwater scientists. Every freshwater scientist wants to see it at some time in their life, but very few from us in the West have had that opportunity.
What can you tell us about the history of research in the lake? We've obviously been aware it's pretty special for a long time. And is it true that there's been one family of Siberian scientists who have sort of multi-generational studies?
Absolutely. The lake was first studied back in the 1800s. I mean, there's been a number of freshwater scientists, Russian freshwater scientists who have worked there. There's a very long history of work on the lake. Now, I basically stumbled upon this family, 3 generations of the Kazov family have studied Lake Baikal beginning in 1945. So Professor Mikhail Kazov, he began initiating a data collection program in the pelagic waters of Lake Baikal, a very intensive sampling program that involved going out every 7 to 10 days, even through the ice in the winter, and collecting samples at 8 different depths down to about 250 meters. And so he and his staff and students were quantifying water temperature, water transparency, and then phytoplankton biomass, phytoplankton, zooplankton species composition. And when Mikhail Kazov died, his daughter, Olga Kazova, took over this program continuing it. And when she died in 2000, her daughter, Lubov Izmesteva, who is my colleague, continued and sustained the program through about 2011. That's when she retired. And the program is still continuing. So there's more than 80 years worth of high resolution plankton data that has been collected. The Russians are superb taxonomists. And they have identified the phytoplankton and zooplankton to species, and they have even aged the zooplankton.
Can you lay out the sort of biological conditions? Obviously, it's frozen for some of the year, but what is special about it from a biological bent is it's sort of well oxygenated right the way down, which is unusual for such a deep lake.
I'll talk about the ice first. I mean, the ice cover, it lasts 5 to 6 months, 5 months in the southern end of the lake, about 6 months up in the north end. Because this lake is so long, it's over 600 kilometers in length. There's a seasonal delay between the north and the south end. And the ice is absolutely essential for the lake's pelagic food web, because there are organisms at the bottom of the food web, phytoplankton, and at the top of the food web. That's the Baikal seal, which is the only true freshwater seal in the world. Both of those organisms or groups of organisms require ice for reproduction and population growth. For example, the Baikal seal gives birth in ice caves or ice burrows that are scratched out on the surface of the ice. And this is where the pups live for the first 1 to 2 months of their life before they enter the water. And those caves are very important because they protect the pups from terrestrial predators like crows, humans, bears. And another interesting aspect to the ice is that it influences the fertility of the female adult seal. The adult seals molt on the ice every year, and molting is energetically expensive. The seals do not feed when they're molting. Now, if the ice goes off exceptionally early, which it does in some years, molting is then delayed. And that causes female fertility to decline, by as much as 60%. So you can see how important that ice is to the seal. And then the phytoplankton, there's a very important group of phytoplanktons called diatoms. These are endemic, found nowhere else in the world, these particular species. And they bloom. In other words, their maximum population growth occurs under the ice because they prefer dim light. The ice reduces the light to an optimum level for maximum photosynthesis and population growth.
Wow, you always think of more light as better. But the ice is incredibly clear, isn't it? I've seen some beautiful images of it like glass.
Yeah, that's right.
So if we're getting through the ice and we're down into the water now, there's some unique conditions there, isn't there?
Yes, there are. Now, it should be no surprise to anyone, I guess, that the temperature here it's a very cold lake. Surface temperatures average 5 degrees C annually. Now, once you get below the summer thermocline, and summer is very brief, about 7 weeks, once you're below 20 meters, which is the bottom of the thermocline, temperatures are pretty much constant, and they're about 3 degrees C all the way down to the bottom of the lake. So quite similar to the deep sea, cold, constant temperatures. Now, the oxygen concentrations in Baikal are very high throughout the entire water column, all the way to the lake floor. And I think here's a difference between Lake Baikal and the oceans. There's no oxygen minimum zone in Lake Baikal. And let me emphasize another point. This is the only deep lake in the world with oxygenated deep waters. And when I say deep lake, I'm talking about lakes greater than 800 meters. And this is really important because it's allowed the evolution of multicellular life in the deep depths of Lake Baikal.
Yeah, it's led to some incredible deep water specialists where that niche isn't usually open. They're physically deep enough, but that oxygen minimum, acts as a barrier to complex life. And so we'll get on to some of the exciting endemic species in there. And then just to make it even more incredible, then at the very bottom, we've got geothermal activity as well. We've got vents, we've got seeps.
Yes, yeah, absolutely. Those are just fascinating. And it is because, oxygen is present down at that deep depth, and you have this geothermal activity, which is releasing methane. And the Baikal vents and seeps are similar to that in the ocean chemically, but their physical environment and the animals in Baikal are very different. In Lake Baikal, just as in the oceans, there's lots of dissolved oxygen, lots of dissolved carbon dioxide, and methane. And so you have all the chemicals necessary for these what are called chemoautotrophic bacteria. And they're just incredible because they can make sugars using chemical energy rather than solar energy. So these bacteria sustain life, entire food webs where there is no light. And there is no light in Baikal at the vents which are down around 400 meters. The seeps are even deeper. Now, let me say a little bit about the physical environment of the vents in Baikal. The temperature of the fluid coming out of the vents in Baikal is much cooler than what we see in the ocean. The maximum temperature is about 16 degrees C. But of course, that's considerably warmer than the ambient cold waters, which are 3 degrees C. Now, in the oceans, the fluid coming out of the vents can reach a maximum well over 400 degrees C. So ocean vents are much hotter. Another difference between the physical environment of vents in Baikal and the ocean is that there are no black smokers or chimneys in Lake Baikal. But the vents in Baikal are located on a soft substrate, and that soft substrate is covered in a mat of these bacteria that can manufacture sugars and sustain food webs. And the macrofauna, it's very different, a very different fauna. At Baikal, you see low-growing sponges that are white, gray in color, planaria or flatworms, and small crustaceans, such as amphipods, ostracods are present. And there is a fish that has been fairly recently described that appears to be associated with these vents. It's an endemic sculpin called Neocotis thermalis. But the important point here is that the vents at Baikal do not have the colorful large tube worms or the giant clams that we're familiar with at the Pacific vents. Now, if we quickly turn to the seeps, at the seeps in Baikal, there are amphipods, giant planaria, oligochaetes, these are freshwater segmented worms, and this is the big surprise, there are aquatic insects down there at 300 to more than 1,000 meters depth.
Wow.
And these insects are midges, or what we would call flies. The adult life stage emerges from the water, and it looks a bit like a mosquito, but it's non-biting. And no one knows how these insects ascend that deep water column to get up to the water surface to emerge, when they're ready to pupate. But it's thought that the bubbles of gases such as methane that are associated with the seeps help to carry those insects up to the surface.
I'm amazed at the insects. Oh, there's parallels, but everything's just a little bit different.
That's
I continue
right.
to learn more stuff and just get more and more intrigued by this place. So we're seeing all these unusual groups. We're seeing these groups that we're familiar with doing life in a way that is unfamiliar. I'm still reeling from deep water insects. So the endemism is really, really high. So where have these animals originally come from? How was the lake originally populated, and how have they now specialized in these weird ways?
Oh, I think that's still a mystery, how these species have arrived. One potential way they could have entered is via rivers, and that's certainly the hypothesis regarding the entry of the Baikal seal. The hypothesis is that the ancestor of the Baikal seal was related, or possibly even a ringed seal up in the Arctic, and during the last glaciation, it traveled down the Yenisei River into Lake Baikal, where it evolved into the Baikal seal and remains today.
And I'm biased. I'm pretty honest about it, but I'm a fishy person, and the fish in this lake are mind blowing. So we've got the deep water sculpins, the oil fish, and they have occupied this very deep water niche. And some of them are there's real sort of polar Arctic sort of traits to them, sort of transparent and fragile. I see body forms that are parallels to what we see in the deep sea fish.
No, you're absolutely right. And what you're describing are the two pelagic endemics which dominate the fish biomass in Baikal. These two species are referred to by the Russians as the Golomyanka. And these two species, their biomass across the lake surpasses that of all other fish in the lake. They're very abundant because they're found from the bottom of the lake up to about 300 meters, even 200 meters. They're very strong vertical migrators. Their characteristics, their physical characteristics, make them look like they belong in the bathypelagic zone of the deep sea and the ocean. They have no pigmentation. They're white in color. They look like an albino fish because, they live in perpetual darkness. So why be colorful? They have tiny eyes. They have very large mouths for consuming anything that comes by, which includes each other. They are cannibalistic, and their body size is small. It's a large Golomiaka. There are two species, the large and the small Golomiaka, and the large one, its maximum length is 20 centimeters. So these fish are small, and they're, as I think you mentioned, they're very oily. They don't have a swim bladder, because a swim bladder would certainly be disadvantageous if you're a strong vertical migrator. If you're moving up and down that water column every 24 hours, a swim bladder would either implode or explode.
Yeah, there's a lot of energy to inflate and deflate the floaty. Better to have something uncompressible.
Yeah, so these fish are very oily. The large Golomiaka, 40% of its body weight is oil.
Wow, that's up there with the sharks, with the deep sharks.
Oh, is it really?
Yeah, that's huge.
Well, the Russians also call this fish the candle fish, because Russians in the old days used to dry the fish and burn it like a candle because of its high oil content. And then another feature that harkens to the deep sea fish is that the Golomiaka, they are viviparous. They give birth to live young, as do many of the fish, I believe, in the deep sea. And they're just amazing fish to see in the water column, because they have these very large pectoral fins, which they hold out, and they sometimes float upside down, with these fins extended outwards. And so another common name that you hear Russians use for them is the angel fish, because these fins look like the wings of an angel.
These are fishes in the suborder Cotidae, which is the same as the snail fishes we find in the deep trenches, and there's a similar sort of body form to it. Again, those big pectoral fins.
Oh, wow, cool. I didn't know that.
Yeah, the snailfish were recently sort of moved from the perciforms. So yeah, as usual, genetics is shaking the tree a little bit, but it's really interesting that we're seeing similar body forms. We're seeing at the deepest reaches of this freshwater, like this same lineage coming up.
Absolutely.
And their history is a thought that it's a polar adaptation, it's a cold water adaptation that then leads to a depth tolerance and allowed them down into the trenches. So that it's just amazing parallels. And there's another parallel as well, because one of the most abundant things we see in the trenches is amphipods, and they are nailing it here. They are winning.
They absolutely are in Lake Baikal. Oh, that's interesting. I didn't know about the abundance or the presence of amphipods down in the deep trenches. That's very cool. Let me say just something quick about the amphipods. That group of organisms in Baikal have speciated the most. There are well over 350 species of amphipods in Lake Baikal, and all of them except one are benthic, living on the substrate. But 98% of them are endemic. They're found nowhere else. And to help your listeners, I guess, appreciate how amazing this is, more than 350 species. Most lakes have about 2 to 3 species in them. So the amphipods are kind of like the Galapagos finches. They've really adaptively radiated in Lake Baikal. One of the groups that I really enjoy are the sponges, particularly the species that form these sponge forests look like something that's come out of the Caribbean or the Great Barrier Reef, because there's a family of sponges that occur actually in the nearshore waters from about 4 meters down to 20 meters. And they do form sponge forests because they can stand as high as 50 centimeters. They're highly branched, and they're a vivid emerald green because of a symbiotic alga that lives in their tissues. And so they are stunning, but there's a very sad, coda to this story, and that is that a pathogen has swept through the nearshore waters and has killed many of these sponges.
Oh, that's a shame. I saw the images of them, and a lot of people don't even associate sponges with freshwater systems, let alone forests of ones half a meter high.
And divers come from all over the world to see those particular sponges, but they are very, very hard to find now.
Oh, that's a shame.
And they're very slow growing. There's estimates that it may take another 100 years for those forests to come back.
And that's assuming the pathogen has gone.
Yeah, good point.
Another thing that we see similar to the deep sea and certainly the abyssal plains is there's a good scavenger community here, isn't there? I think you yourself did some baited experiments, and there's a good cleanup crew.
Yes, there is. There is a local legend among Russians that the Russian mafia prefers to dispose of human bodies in Lake Baikal because there's nothing left after 48 hours. There's no flesh left, that's for sure. And my students were very intrigued by this, and we tested that hypothesis by placing baited fish traps along a depth gradient. I think the deepest depth was 200 meters. And that was a funny experiment because the captain of our ship insisted that we bring those traps in before 48 hours because he was worried there would be nothing left. And so we finally gave in and brought them in slightly less than 48 hours. And he was right. At least a third of the traps were completely empty of all the fish. And there was a lot of fish in those traps. And then 75% of the fish was gone in all of the other traps. But what was in those traps were these amphipods. I mean, there must have been 200 to 300 of them in each trap. And they're really quite small. The species that act as very effective scavengers, they look like orzo, about the size of that pasta, maybe a centimeter long, pretty much white in color. But wow, I was impressed by that. And to give you another example of how effective they are at scavenging, fishers in Lake Baikal, people still use gill nets in Lake Baikal. They probably shouldn't be, but they do. If the bottom of it is floating a little bit close to the substrate, those amphipods will jump up onto that gill net and basically eat the fish. So they're pretty impressive.
Oh, this feels super, super familiar. I can send you some pictures of some deep sea traps that must look exactly like what you're describing, because that's exactly what we find. And we find that they swarm like bees. We often describe them as like a swarm of bees. And yeah, they will overwhelm the fish as well. They'll overwhelm their own predators. The snailfish often are preying on them, but it seems that they can get outnumbered and overwhelmed by the amphipods, especially in a confined space. Oh, they're wild. They're fierce little things.
Yes, they are. I'm really amazed at their olfactory capabilities because I think that's how they're sensing these food falls that fall to the lake floor. And they must be recruiting from great distances for a small amphipod. It would be fun to look at that.
Yeah, it's not just the capability of eating. They have found this prey in a fraction of the amount of time. It's just 10 minutes they must be finding it to be able to strip it within 45.
Yeah, I imagine the same thing happens to the Baikal seal when they die. They're probably gobbled up by these little amphipods.
Oh, I bet.
Before I forget, there's one other abyssal giant in Lake Baikal that I've been very impressed with. I've only seen Russian video footage of it, but it's a flatworm, and it's 30 to 40 centimeters long, and it glides across the bottom of the lake floor like a flying carpet. I mean, it really moves. It just kind of undulates across the lake floor. And this was absolutely stunning for me because freshwater flatworms, the largest are about 5 millimeters long. And to see something that big was really jaw-dropping.
Oh, I've got a friend who's a big flatworm guy. He must know about it, but if there's footage, because that just sounds incredible. These are infauna. These are things you sieve and you look at with a microscope. So one a foot long gliding across the sediment. That's incredible.
Right.
So another aspect that your research touches on is human impact and human influence on the lake. It's sort of multifaceted, really. There's a few things going on. What are the human impacts on the lake? Or is it the global human impacts? Is it our effects of climate?
Great question. In my opinion, well, in fact, I think the opinion of many people right now, many aquatic scientists, the greatest threat to Lake Baikal is a local threat. It's unregulated development and lack of sewage treatment along the lakeshore. There are certain bays, certain locations that are very attractive to tourists. And that's where these problems are very severe right now because untreated sewage is flowing into the nearshore zone. And that's where the greatest number of species are in that nearshore benthic environment. And this really started back in the early 2010s. Tourism absolutely exploded at Lake Baikal. And there are not adequate facilities to cope with this explosion of humans visiting the lake. Not even the Russian dachas. These are small vacation cottages that the Russians own. They don't even have sewage treatment. All of the buildings, all of the dachas are serviced by a cesspool, which is simply a hole in the ground into which human waste goes. And of course, that waste makes its way into the nearshore zone and a whole host of problems. have cropped up from that, from E. coli being in the water, which is very dangerous to humans if they drink that water. When my students and I first went to the lake in 2001, we could drink the nearshore water without any treatment. You would never do that today. And then there's toxic cyanobacteria, and the real problem is the explosive growth of a green alga that grows on the substrate. It forms these green clouds of filaments and can smother life underneath it. So in the short term, over the next 20 years, this problem has really got to be tackled. And in the long term, I think you're right. I think there's a global problem on the horizon, and that's climate change, because there are ice-dependent species in this lake. The duration of ice cover is shortening. Ice thickness is being reduced. And then, of course, there's the warming of the water, which we've documented using the Russian 60-year data set. And many of the endemics in this lake are cold-loving species. They have a narrow temperature tolerance range. So there's a lot hammering at Lake Baikal right at the moment. And in my opinion, the number one thing that has to be tackled first is the problems in the nearshore zone, because with climate warming, that problem will only become worse.
Just to follow on from that sort of description of the human element, what is it like to study in this area? Like, what did your visits feel like? Obviously, it's quite a remote. There'll be a lot of travel, and then what's a day in the life like studying?
The travel is grueling. It really is. I mean, once you get to Moscow, you've got a 6-hour plane ride, a red-eye flight to get to Irkutsk. That's the nearest large city, and then there's a bus ride or car ride about 45 minutes out to the nearest port. This is what we've always done, and then we take a ship for about another 45 minutes north along the lakeshore to the biological station where we've always worked. And so when we arrive, we feel like we have traveled to Mars. we are very, very tired and badly jet lagged. A day in the life, yeah, good question. Being out in the water is just, it's fabulous. There are mountains on both sides of the lake. On the west side, which is where most of the tourism occurs and where the biological station is located, but it's in a very, very small village, the biological station. It's just lovely, having those mountains there and these very narrow valleys with streams coming down to the lake shore. I hope that gives you some sense of what the lake is like. And the Russians are just incredibly hospitable. We have found them just very warm and curious. Many Siberians have not traveled much beyond Russia, and so they're curious about the world and interested in you. And if you can muster or learn any Russian, they will be absolutely delighted.
Oh, it just sounds an incredible experience. I'm going to have to figure something out. Thank you so much, Marianne. I knew it was going to be exciting, but that was amazing.
Well, thank you, Tom. Please do send me some of your papers and your pictures. I so much enjoyed listening to you. I want to see it's a snail fish, right? I want to see that. And I want to see those amphipods, the gigantic ones and the little ones. And it was just a delight to talk with you.
Oh, thank you so much. Well, there's a thing I say at the end of the show quite often, and it's not a joke. I'm sincere. The podcast is a way of me bludgeoning people with my friendship. So we are friends now.
Oh, good.
And I'd love to keep in touch and share some work.
Absolutely.
And we've stayed chatting after the interview. She did have some corrections for us. It's about 60% of the animal species are endemic, not 80%, which seems to be a figure that crept into some of the publications, and it's kind of been repeated a lot now. So that was one of the things she'd like to push back on, is that it's more like 60%, which is still huge. That is crazy that over half of the animals in this lake are found nowhere else. And that was a pressurized version of one of our longer episodes. If you enjoyed that and you would like to hear the full length episode, just match the episode numbers and you'll be able to find the full length version in the feed. Thanks for listening. We'll deep see you next time, and I abyss you already.